In this video, I will continue going over the code for chapter 2 of the book Practical Propensity Score Methods with R. And I will focus now on using logistic regression to estimate propensity scores. So this code is available in the website www.practicalpropensityscore.com, and it's the code. The file starts with chapter 2, and I'm starting on line 91, which shows how to estimate propensity scores with logistic regression. At this point, I have two data objects that I'm going to work with. Imputation 1 has one imputed data set. So imputed data set is the original data set with all the missing data replaced by predicted values. And also have another data set called all imputations, which has 5 versions of the original data set with different values used to replace missing data. So the first step of estimating propensity scores is creating a vector of variable names. Those are covariates that you believe they are true confounders, because they are related to both treatment assignment and the outcome. So here, for this example, which is to estimate the effect of career academy participation on student income in the future, I'm using these covariates that are listed here. So my vector of covariate names is pretty long. Okay. Now, after that, this data set also has dummy missing indicators that I created when I was handling missing data. However, it's possible that the two variables have the same missing values, which means that the information about missing data is redundant across the two variables. So in this step, I am removing missing indicators that have correlations that are very high, meaning they are redundant. So it's not a very sophisticated way to do this, right? First, I'm creating a matrix of correlations between missing value indicators for variables that have at least 5% of missing data. Then I am identifying which variables have correlations less than 0.8, and I'm only selecting missing value indicators for those variables that have correlations less than 0.8, which, I mean, they are not redundant. There are more sophisticated ways of doing this. I could have used VIF, variance inflation factor, which is a way to check multicollinearity. But this, just taking variables with correlations less than 0.8 works well enough in this case. Now I'm creating a new expanded covariate names vector, which has both the covariate names and the dummy NA names, which are the names of the missing data indicators. I am going to show you how this is like. So notice, for example, I have two versions of BYPLang. So BYPLang is the parent language of base year. It's the original variable and it is missing data on it. So I also have BYPLang NA, which is a 0-1 indicator. So it's a dummy indicator of whether BYPLang had missing data. Now this BYPLang here doesn't have missing data anymore because it was imputed, like we imputed the missing data. But BYPLang NA codes that information of whether there was missing data to begin with into a 0-1 factor. Now, I want to create a model to estimate propensity scores. So this is a logistic regression model. I could write the formula, by typing it here, but with so many covariates, it would be very long. So basically I would have to put a plus in the middle of the names of all these covariates. There is a more automated way to do that, which is using the function paste, which gets the covariate names and puts a plus in between them. And then I use paste a second time to put treat by, because I'm predicting treatment. And I end up with the formula automatically create. So that's my formula. Notice that I took the covariate names, put a plus, and then added the treat till here. I will use the survey package to run a logistic regression according to this equation, because the data set that we are using has a complex survey design, and they were stratified, multi-stage stratified sampling was used. So that is cluster IDs and strat IDs, and their sampling weights, because unequal sampling was used. So I need to account for that when I run the logistic regression. So the variables I have, PSU is the name of the variable for the cluster IDs. Strata ID identifies a strata, and BYSTUWT is the sampling weights. Okay, so the package survey allows me to run a logistic regression, take into account that complex sampling design. At first, there is a PSU, a cluster with just one strata, and I have to use these options here to say I'm going to adjust for it, or else I get an error. It only happens when you have a PSU with single strata, and you find that out by looking at your data, or you run the next step and get an error, and you have to go back and run this step. Okay, now the first part is to define your survey design. So I'm using the SV design package. I'm saying that the IDs here is not the individual ID, is the cluster ID. So I'm saying that my cluster ID is PSU. My strat ID here, strat identifies strat ID, is named strat ID. My weights are BYSTUWT. My data is called imputation 1, and to nest the strata within PSU. Now, the data imputation 1 means that I am, in this one, I'm defining the survey design just for the first imputed data set. Now I do the same thing in the next line, line 165, for all imputed data sets. So I go the survey design all here. It's the same specification where I specify the PSU, the strat ID, the sampling weights, but now I'm saying that data is all imputations. So the 5 imputed data sets. And then I feed the logistic regression twice. The next step is feeding the actual logistic regression to estimate propensity scores. I'm using the function SVY GLM of the survey package. And to run the logistic regression, I provide the formula, which is this formula here. Then I provide what the survey design is. In this case, I'm using the survey design for just one imputed data set. And then for the family, this is where I say it's a logistic regression. Now, for logistic regression, usually we use family equal binomial. However, when you have sampling weights, you have over dispersion. So instead of using family equals binomial, I use family equals quasi-binomial. So if you want to understand more, you can read on over dispersion in binomial distribution, and that will give you more information about that, why I need to use quasi-binomial here. Now the next line, I feed the logistic regression model again, but instead of feeding it to a single imputed data set, I feed it to all 5 imputed data set. So it's the same, except that now I'm using the survey design with all imputed data sets, and that's the only difference. Okay. Now to obtain propensity scores from a single imputed data set, remember propensity scores are predicted probabilities of treatment assignment. I use the function fitted. So fitted gives me the propensity scores, and then I assign them to the data set. Like you can see here, if I run this to show you, these are the propensity scores. You know, these are all predicted probabilities. Now, to get them using all imputed data sets, I have to use the function sapply, which applies the function fitted to all imputed data sets. So for here, I get a vector of propensity scores instead of a single one. I use the function head just to show you the beginning of it. So you see, like I have here now 5 columns of propensity scores, 1 for each input data set. And note that because of the missing data, there is some variability in the propensity scores across input data sets. And that's a good thing because it is accounting for the uncertainty that comes from using imputed data sets. Now I decided to convert from 5 imputed data set, 5 vectors of propensity scores to a single vector of propensity scores by taking the mean across. That is one approach, but there is a second approach, which is to run a separate propensity score analysis for each of these 5 imputed 5 propensity score vectors. So you would run 5 separate analyses. That the approach is superior because accounts better for the uncertainty due to missing data. But here I'll use, for now, I will just average across the 5 imputed data sets to get a single one. And then I will add the mean of propensity scores to our imputed data sets. So this is how you estimate propensity scores using logistic regression for both a single imputed data set or multiple imputed data sets. I will stop here in this video. The next video that you should watch is on how to use propensity scores, how to estimate propensity scores using classification trees, which is a data mining method.